So in my last video, I proved that a linear function is always going to be one-to-one. And in this video, I want to prove that f of x is equal to e of x is a one-to-one function. And this is known as the exponential function. And what I want to do is I want to show that it's one-to-one. So a function is going to be one-to-one, given that whenever f of x equals f of y, then x is going to be equal to y. So the first thing we want to do is we want to write proof, and we're going to start off by assuming that f of x is equal to f of y. So we want to assume f of x is equal to f of y. So we're going to start off by assuming that this is true. Now we know that f of x is equal to e to the x power. So I can replace f of x with e to the x power. So I'm going to replace that with e to the x power, my exponential function, and then I'm going to bring down my equal sign in the middle. And then over here, this is a function of y. So instead of having e to the x power, I'm going to have e to the y power on this side. So now I have e to the x is equal to e to the y, and now I need to do some work to show that x equals y. Well, to do that, I need to be able to get rid of this base. So what I'm going to do to both sides is I'm going to take the logarithm of both sides, the logarithm with a base of e. So I need to take the natural logarithm of both sides. So I get natural log of e to the x is equal to natural log of e to the y. The natural log and the e kind of cancel each other out, and that's going to bring down the x on this side. And then over on this side, the natural log and the e are going to cancel each other out, and then the y is going to come down. So I get x equals y. So now that I've shown that x equals y, I can now declare that this function is one-to-one. So I write therefore, f of x is one-to-one. And I'm done with my proof. So that's one of the functions that are one-to-one.